example 9. An examination has a mean mark of 60.7 and a standard deviation of 12.3. You may assume the marks follow a normal distribution. Part 1. A candidate needs a mark of at least 40 to pass. What percentage of candidates fail? Let's deal with that bit first of all. So we know it's a normal distribution, and we know we've got a mean of 60.7 and a standard deviation of 12.3. Now writing that out, don't forget it's 12.3 squared you need to write as the second parameter in your brackets. Our diagram, very straightforwardly, will look like that. Right, so 40 on our scale will be to the left of 60.7, so down here. Now we know 40 or higher will mean a pass, and we're interested in how many fail. So we're looking at the proportion that get less than 40, i.e. the probability of being less than 40. So I want the probability of x being less than 40. I need to convert that to my standard normal, z, by taking away 60.7 and dividing by 12.3. On my graphical calculator, I can work this out. Now we're working out a probability, so norm but NCD for working out a probability. We put in brackets 40 minus 60.7, close brackets, divide by 12.3. That gives me a z value then of negative 1.6829. So that's what I'm trying to find. If I scroll down, it'll draw me a nice picture and tell me that the probability is 0.0462. The question actually says what percentage of candidates fail. So my answer is 4.62% candidates fail. Okay, the second bit of the question says that the board awards distinctions to the best 10% of candidates. Find the lowest mark required to gain a distinction. So same distribution as before, but this time we're looking at the best 10%, i.e. the highest number of students, and we only want the 10% of them. So I'm looking at a value that I don't know, that's the mark I'm trying to find, but I do know that this proportion is 10%. So I'm trying to find the value here, and we know that the probability of x being above that value is 0.1. Can't deal with greater thans, so need to turn the question round. 1 minus the less than probability will be 0.1, i.e. the less than probability is actually 0.9. I need to convert this to z's by taking away the mean and dividing by the standard deviation. I don't know the z value itself, but I do know the probability is 0.9, and I can find out what the z value should be using the inverse normal. So now I need to come out of this but go back in distributions normal, but this time inverse normal. My area is 0.9. Scroll down and work that out. So that tells me that this z value here is actually 1.2816. And then to solve that, I simply times up by the 12.3 and add on the 60.7, and that gives me a mark of 76.5. It doesn't make clear in the question whether the marks can be whole numbers or not, so I think we will get all of the marks for that.